I don't know, chemistry practical has never changed. Nothing actually is changing in the chemistry practical. The first question is normally the quantitative, uh, which when I say quantitative, naongelea maneno ya the moles. What do we do the titration? So it never changes. Now, the second question and the third, if there is. Now, previously, some years ago, we used to get two titrations. That means you'll only have a second question. So two titrations used to take up most part of the. So we used to have two titrations. They take most part of the marks. But last year, I don't know, last year, the same. I think last year we had two, if I'm not wrong. The previous year it was one. I don't know. They are still changing, but titration is titration. Never the case. Um, Nevertheless, you are supposed to read, especially when you have two titrations. It is normally very dangerous. Uh, because of now you are supposed to store what you use in question one so that you can use in question two or B, A and B side. So you are not supposed to pour out everything as we start. But anyway, that one, but now I wanted to do the qualitative analysis. These ones now is the notes that I will share. I'll not share the other one because I thought the other one is a little bit confusing. So I had to scan mine the other day. I said I will share it. I was looking for it in my, so in the school laptop, I could not really locate them. So and then I was like, I have the hard copy. Why did I just scan the hard copy? So here is now the ones that I normally use. So specific objectives of chemistry practical. Number one is to test if the student is able to select handle apparatus for use in an experimental work. So you are supposed to know how to handle the apparatus, especially when you're talking about the titration, how you can connect the bose and the clamp with the burette. That is number one. If you can use the pipette filler or your mouth to suck and transfer liquid to the conical flask. If you can swirl as you titrate against that solution, those are the things that you're supposed to know. If you can follow the instructions that could add three drops of the indicator, if we are adding in that case, which I will show you, there is a question in this one that does not actually add. Also, I've shared some of the practicals that you'll be doing at the end of that April. So kuna zingine nimeshare. One of them will be having the oxidizing agent. So there will be oxidizing agent and then it will change. Of course, now the good thing about titration is kama unajua kuifanya, hata swali ikuja aje, there is no problem. You still score your marks. Now, number two is to test if the student is able to use either theoretical understanding of chemistry to make accurate observation and draw conclusions from those observations. This one applies mainly to the qualitative analysis. The one that we are going to talk, sodium hydroxide, ammonia, it applies mostly to those ones. But also observation that comes in when you're doing titration is the color changes that normally happen. So color imebadilika ikakuwa, for example, it was purple, it can change to colorless. Now, do you stop the reaction or do you continue titrating? Yeah, those are some of the things. So if you can understand those, that theory of color change, especially when you're talking about the wachana na oxidizing agents, when you're talking about what do you call this? Why is the name indicators? When you're using the indicators, the color changes in indicators, and I'm saying this because the color change in indicators has been discussed from Form 1 all the way. So you are not supposed to forget about that one. But the good thing is you will be told in the question. I'll show you a question that has that one. Then you will see. Now, and then number three is to test if the student is able to make accurate measurements. And accurate measurements is actually maneno ya sasa when you're pipetting. When you're transferring, for example, if you have two titration, you'll have to transfer it into a volumetric flask and then you just fill it to that mark, those ones. So areas commonly tested in practicals. Now, all of these ones I've considered in the practicals that I've shared. So number one is a qualitative analysis, organic, organic and inorganic. That one is very important. Organic chemistry is there. I'll show you. And then we have inorganic, niyo maneno ya ions now, cations and anions. That one is inorganic. But we have organic, which is kina alcohol, kina alkanes, alkenes, and alkynes. That one now for the organic chemistry. Inorganic, tunaongelea kina metals, metal ions. Now, quantitative analysis in a titration. So I can say titration, which you have done. The only part that is remaining actually in titration is to do the titration itself. Your titration itself. Do people understand how to do it? Of course, we complete titration. I think tomorrow, no, not tomorrow. On Monday, I think we'll complete that one. Maneno sasa ya redox. I think we'll complete that one, and then we go to a small part of air, atomicity of air. So that one is very shallow. But the most important thing is to know maneno ya quantitative analysis. Yeah, how to do the titration process itself. Now, another area that is there is normally graphical work. You are given maybe the rates of reaction, and then you are told now to plot a graph. Now, I want to talk about the graph for maybe a minute or so. Now, when I was teaching the source, tuliguza graphs. I hope everybody was there. If you are not there, I think it was also recorded. Now, when you are drawing a graphs, I have a problem everywhere of students not following the rules of drawing graphs, where we are told. Now, rule number one, of course, that is common sense. One, penseli inatumika kwa graph. Use a pencil. Whether you are pali huko tu, where tumia, use a pencil. It doesn't matter. It is wrong when you draw a graph using a pen or something that cannot be rubbed. It is wrong. It is wrong. That is number one. Number two is choosing a very good scale. Scale yake ikuwe mzuri so that you can use 3/4 of the page. So scale ikuwe mzuri so that it can cover 3/4 of the page. And then of course, when you are plotting, do not use dots. What I'm saying is this, huh? Let me just write something. So if you are drawing a graph, so number one, you use a pencil. Number two, don't use dots inside the graph. Now, when you want to plot maybe a line, because most of the time it is a line, line graph. Most of the chemistry is line graphs. We don't actually do bar graphs and the geography and the rest. So you don't use dots that way in the drawing. Just use a star. That's what I said. So that in case you are doing a line, to me a dot line in a measure your dots. But when you use an X, it can be visible. So you use that one. And this one is my page, of course. If this one, for example, is my page. Nilisema, you jump 2 lines, you skip 2 lines. So if these ones, the big ones, the ones that you count, the small box is 10. So you can skip 1, 2, yeah, and then you can skip 1, 2, yeah, so that you can use it for. So the first line is for the numbering. The first line. The second line is for naming that axis. The same with this one. So you numbering the first box, the first cubicles is for numbering of the axis, which is in this case the y-axis, and this one is the x-axis. So unaandika, for example, if it was energy. So the first line, 10, you name now 10, 5, 0. Yeah. And then this second, now the first one in your it can be used for naming. So you name the axis. For example, if it is energy, naandika energy. And then this one is, you name this one again, 0, 10. And then the second, the one that you skip, you name temperature. So that it can be very nice. And again, I normally tell students that it helps you make sure that you have used 3/4 of the page. Because the graph actually is from this part, naming. inaanzia hapa zote mpaka pale line yako imefika, ina fall under that graph. So it is very wise what some of the students wanafinya hiyo graphic ndogo, which is wrong. So you lose marks for, and the only problem with graphs in chemistry is it normally has very few marks. It normally has very few marks. So about 3 marks, I think 3 maximum. But where the maximum marks go now, marks mingi pali naenda is filling that table ya graphs, especially when you're given the rates of reaction. Now, I have also shared a practical that has the same, so that you can learn how it can be done. Now, so those are the common areas that are tested. Now, this one is a series that I did in 2018, but nothing has actually changed. It's still the same thing. So that is why I have not changed it. Yes. So the common areas that are tested is still the same. So that is why bado inaandikwa a guide of 2018 series. Yeah. So but there is no problem. Now, number one is the qualitative analysis. Now we had discussed this one, but I thought maybe these notes now are clear, and I'm hoping that everybody can see. Now, these are the notes that I'll share immediately after we are done today. I did the scan yesterday, so I had to scan it. I had to make sure that they were clear. And I checked that it was good. So I'll share them today. Please use these ones immediately when you're almost starting the practical. Maybe mid April you can start going all through them. So we have so it refers to carrying out chemical studies on substances which with the sole aim of identifying them. So qualitative analysis, we want to identify what are these ones. We are given something we do not know. So to be able to identify them or to get good results, one, you accurately identify the test reagents. If you mess up in the test reagents, for example, wamekwambia tumia potassium manganate 7, and then you decide to use bromine water, most probably you will lose the answer. So I normally say when you go to the practical session, especially the qualitative analysis, the first thing you're supposed to be worried about is, do you know the reagents that you have been given? For example, do you know how to write sodium hydroxide? Do you know how to write ammonia or ammonium hydroxide? Those are the most important things that you're supposed to know. Kama hatujui the chemical formulas of the reagents, then we are finished. Of course, now the good thing about the indicator is they will write in full phenolphthalein indicator, or they will say it is methyl orange. Those ones are easy. Now, maneno ya barium nitrate, lead nitrate, for example, something sulfate, HCl for hydrochloric acid, those forms are dangerous. Sulfuric acid, sometimes they say they have given new nitric acid. Iso, they are very dangerous. So you are supposed to know how to do that. Now, so number two, identify what these agents test. So which I'm going to give now. So you are supposed to predict hii kitu tulifunzwa kwa theory inatumika kutest nini. For example, test for sulfates actually is taught. Test for nitrates inafunzwa kwa topic. So how we test the gases, gases that burns with a pop sound, tulifunza hiyo. Test for carbon dioxide, hiyo ilifunza. So unaweza ona, ukiona calcium hydroxide, unajua hii most probably ina test CO2. So CO2 inatoka from carbonates. That one is how we can know, predict or identify what these reagents taste. Unaona hii tulifunzwa ina taste nini. That one is very important. Now, if you predict now what the reagents taste, you can predict the expected result. Yeah. So unaweza jua ina taste nini na inatoa. So number one now, which is normally very dangerous and very confusing. It normally takes around 8 marks if it was to be shared. This one normally takes the largest amount of marks actually. Mara mingi. Or it can be shared. Now, inorganic and organic can be shared so that, but this one normally is wider than the inorganic. Inorganic is very shallow. Organic chemistry is very shallow, but inorganic is very wide. So it has a lot of questions That is why it normally takes up the lion's share of the marks, or the large amount of marks. Yeah. So inorganic is normally test for cations. And now that is why I was saying this one is very clear. So number one, we are saying test for cations, and the cations that we normally test are very many. Now we have sodium, we have potassium, we have ammonium. Now ukiona vitu venye mimi nimeandika, I'm writing the ions. There is a reason I'm writing the ions. Now there is a reason also I wanted to introduce this one. Using these notes, because now it will give me a better, or it will give you a better understanding of what you are supposed to observe and what you are supposed to write, and where you are writing, what you could be thinking is what you call the inference. You are inferring. Yes. So tuna infer. So it involves 12 cations. Now the other one did not bring up all of this. That is why I wanted to bring this one so that people can understand very well. So we have sodium ions, and it is written that way. Actually, kwa inference you are supposed to write in Z. You don't write sodium as in SON, SODIUM, that way. Ions, that one is wrong. You're supposed to write the way it has been written here. Hivi venye nimeandika. So we have sodium. So let me help you so that you can understand. So we have sodium ions, potassium ions, ammonium ions, calcium ions, which belongs now to group 2. So this one is the one in the group 1, excluding the ammonium, which is normally, of course, it is a radical, but it has a radical of 1, oxidation number 1. So calcium, barium, magnesium, those are the 2. Aluminium is 3. And then we have the other ones now remain as 2, excluding ion 3. So we have zinc. Aluminum is written that way. Ions, lead ions, copper ions, ion 2 ions, and ion 3 ions. Now, I wrote it this way intentionally, by the way. It was intentional when I was writing this one, such that I would say, hizi zote za mwisho tatu, hizo is the colored ion. I normally write it that way so that it becomes very easy instead of circling the other things. So we have the colored ions. Zenye nimecircle peke yake are colored ions, where we have copper to be blue, ion 2 to be green, and ion 3 to be brown. Actually, the other time niliwauliza chemical formula for rust. Maybe we can talk about that one so that you understand when I say it is brown. Chemical name for tulisema hii. I think we touched that one. We touched on that one. So chemical name for so that you understand the difference between ion 2 and ion 3. Chemical name for rust. Chemical name for this. Nilikuwa nimeongelea, and I said it is very important for the sake of understanding. It is very important for the sake of understanding. So chemical name for rust. I don't know if you can. Somebody can just unmute and talk. Huh?
Hydrated iron 2 oxide.
What, Monica? Hydrated?
Iron 3.
Yeah, it brings confusion. It normally brings confusion. So it is actually hydrated. Let me just write. I don't have to write hydrated. So it is normally ion. Actually, it is this way. Ion 3. This one means ion 3. So not only that. What is the color of rust?
Brown.
Brown. Yeah. So the reason why nimeleta hii is so that people can know that rust ni brown. Na gani ndo brown kwa hizi ion 2 na ion 3? Nimesema hii ni green na hii ni brown. So you are supposed not to forget that one. or the identification of ion 2. It normally brings a lot of confusion. Actually, that is why I normally use Rust instead. So nauliza watu Rust inakuanga kala gani? Mtu anasema ni brown. Na gani ni brown kwa inorganic, which ions is brown? Anasema ion 3. So you can identify. So ion yenye imebaki sasa ni green, which is ion 2. So if you say Rust is ion 2, it becomes wrong. Yeah. Actually, Rust is ion 3. Okay, but we're just reminding ourselves that, lakini ukitaka kama umesahau, you have gotten confused in the practical session, especially when you're talking about ion 2 and ion 3, we ona tu nje. I know where you'll be doing an exam, there is a house that is rusted. Na ukumbuke rust ilikuwa kala gani. So if you have gotten the observation as a brown precipitate form, of course, now you can. Na nilisema there are very many ways of answering these questions. You will see. You will see. Now we continue. Observation. So when you add addition of sodium hydroxide, drop poison until in excess. I want you to tell me if you are choosing these notes or you are using the other one. So you will
Teacher,
just say, come on, yes?
before you continue, umesema ion 2 iko color green.
Yes, it is green.
Okay.
And then ion 3 is brown.
Sawa.
So nasema ukiingia exam room na uko umesahau colors, because I know we forget. So we are human beings. Hata mimi time ingine nachanganyikiwa. Sometimes I forget some of the things. I get confused. Hii ilikuwa inakuja aje? Was it this or that way? So if I get confused myself, I'll tell you, there's some way that you can answer this one, which I'll show you in one of the questions. I think I did that one especially in the organic chemistry, which you will see. So when we had, so nilikuwa nasema, mnakumbuka the other note that we used the other time, eh? It is the same thing, but you will choose if you are going to take this one. I share this one with you. If you decide to use the other one, it is okay. Unatumia ile ingine, hakuna shida. So addition of sodium hydroxide. Sodium hydroxide is written this way. Actually, this one is intentional. Most of the people will write NaOH. They will not write in full because that what do you call, the white thing that is normally sticker is very small. So ukiandika sodium hydroxide kidogo itakuwa hata students watashindwa kusoma, or it will be very tiny. So I would prefer to write a very big NaOH, meaning sodium hydroxide. The drop is until in excess. So we have those ones that when you observe, ukiongeza, the ones that form a white precipitate that dissolves or that is soluble in excess, the inference that you are supposed to see. Now, I want you to see what I've written. Yeah, it is called ZAP. That is actually how you are supposed to identify. Of course, I cancel this one. There is a reason why I cancel, because students can write ZAP present. Yeah, there is ZAP. It is for zinc, aluminium, and lead. Zinc, aluminium, and lead means ZAP. That is when you add sodium hydroxide, and then you find that it is a white precipitate that dissolves in excess. It is zinc ions, aluminium ions, lead ions, and it is written now at the end of this one, it is present. And that is actually how we infer. So this one is what I left out, because there is another place where students will write absent. Now, let us assume umeingia class na umesahau ZAP, which is zinc aluminium, and then you have decided umefika na ukapata white precipitate lakini ni soluble, lakini umesahau ZAP iko. Yeah, so you can write actually the opposite. So you can write the opposite, which is wrong, but it becomes right in that question. So you don't know which one, which forms white precipitate and then it dissolves in excess. But you remember those ones that are white but insoluble in excess. You see this one. The second one is white precipitate insoluble in excess. So it is magnesium ions and calcium ions present. So wewe umeingia class ukaweka kwa hiyo practical white precipitate lakini ika dissolve. lakini ukumbuki ZAP, unakumbuka magnesium ion. So the answer to question number 1, which I'm calling this one as my question 1, is ZAP is correct. So this one is correct. So somebody else, kuna student mwenye akumbuki hiyo ZAP, anakumbuka magnesium ion, alafu pia anakumbuka nini? Calcium ion, na anakumbuka hizi ni insoluble. So another answer for you is magnesium and calcium ions ziko nini? So another answer is, now you say these ones are absent. I don't know if that one is making sense. Is it making sense? Yeah,
Yes,
so
yes.
kama umesahau zenye ziko, sema zenye haziko. But of course, now the danger of that one is you must be very sure of zenye haziko. Yeah, you must be very sure. And actually, let me just tell you this thing. Hizi vitu zenye tunaandika hapa is actually something that has been tested in source. If you go to source, you'll find now we have sodium hydroxide, and we say hydroxides of group 1 metals, which is sodium and potassium and ammonium, are normally soluble. Now, tukienda kwa hydroxides, you'll find, especially where you were in, when you were dealing with salts in Form 4, you'll find that we have hydroxides. Most of the hydroxides are insoluble. Most of the hydroxide are insoluble. I don't know if you remember those things, but hizi vitu zote ni source. Now I wanted to explain that one especially so that you understand. So kama umesahau zenye ziko, but I don't think you will forget zenye ziko. This is very easy, especially for the first one. Now we continue. White precipitate insoluble in excess. So nimesema ni magnesium ions or calcium ions present. So ukiingia pia class na upate white precipitate insoluble in excess, lakini zenye unakumbuka ni ZAP, unaweza andika hapa ZAP. So I'm going to write in short, which is ZAP is zinc ions, which is here zinc ions, aluminium ions and lead ions. So juu ni insoluble in excess, na unajua hizi ndo zina dissolve, unaandika hawa hawako, these ones are absent. Huyu atapata correct, huyu pia atapata correct. So you can say zenye ziko na zenye haziko. But the only downside of this one is, now if you say zenye haziko na useme umeandika, and of course something that I almost forgot before even we come to this one is hizi vitu, you are supposed to be very keen. You're supposed to be very keen when you're doing it. And again, something that I want to say before even we proceed is, you are supposed to write at least 2 ions. Yeah, you're supposed to write at least 2 ions. Yani kama answer ni 3, if you forget ZAP, you can remember ZA. So ukiandika zinc aluminium ion present, you get, for writing 1, 2, you can score the full marks. But if you write 1, most probably you'll get half the marks. And practical, I think you're aware that in practical people score even 22.5, 22.25. I don't know if you have seen such kind of I don't know if they have marked for you, and unaletewa karatasi na umekuandikia uko na 10.75, unashanga nilitoa wapi? This one, it comes from this one. Of course it will be rounded off, but you will find that the only problem is, what if in paper 1 and paper 2 you get 10 or you get 20.25? Well, that means it will be rounded off. So itajaza ile ingine, which sasa you would have lost 1 mark, and 1 mark in chemistry is very important. So so it is very important to remember that you are supposed to write. Now let me show you now another one that was done very well. Now if you had sodium hydroxide and then there is no white precipitate, hakuna precipitate yenye imeformiwa You have had iron in excess, but there's no. So you are supposed to write no precipitate formed, and then of course not even in excess, or you can put a comma. I normally use a comma. I normally advise students to use a comma to mean it is something else. Yeah, you're explaining. So no white precipitate, no white precipitate. So we have now, these ones are the ones that are present. We have sodium ions, potassium ions, and ammonium ions, which are soluble. All the salts of these ones are soluble. Ama sasa that is present. Ama uandike hizo zenye ziko juu zote zenye zilikuwa zinaform white precipitate haziko. So you can write zinc are not there, aluminium, lead, magnesium, and calcium ions are absent. I hope hapa tuko sawa. I hope you're okay there.
Yes. But now teacher,
Yes, please.
wakati unafanya hiyo experiment, should you start adding the kama ni hiyo sodium hydroxide in drop wise, ama unafaa tu uanze in excess?
No,
Uiweke in excess.
no, you add first. Maybe let me just explain that one. They normally tell you. That's why I was saying we'll do an example. Now, let me just discuss that one before even. So when you add of sodium hydroxide, now let us just make this one very clear. Una add 3 drops. Acha tuweke 3 drops za kwanza na uobserve. Iko sawa? Una add alafu una shake, eh? You just swirl, to swirl, or you just una mix hivi na mkono. You don't uingize mkono, you just shake it and then it mix. It will form white precipitate, yeah? Excess tuweke hata I don't know, do we say 10 drops now? That is excess. Imekuwa mingi, yeah? 10 drops is a lot actually. So wacha tuseme unaona ukiwa add 2 to 3 drops, you observe that one is a few drops. 3. Alafu excess weka yote yenye imebaki kwa dropper. Si mnachotanga na dropper hivi. So unaongeza 1 2 3, that is a few drops. So una shake, unaona kama ina form white precipitate, it forms white precipitate. Alafu excess ni uweke hiyo yote yenye imebaki kwa dropper. Ufinyie tu yote iende, and then you see what will be formed. So that one is clear now?
Yes.
Yeah. So 3 drops, and then you put all the thing that is remaining. That one is okay. That is now in excess, and then you observe. So nasema in no white precipitate, there is no white precipitate in few drops and also in excess. So that is what we are saying. Now, the colored ions. So the only remaining is these are not hard to remember. I want you to check these one. Actually, we are done with the non-colored ions. Na nimesema non-colored ions, we normally consider white as not a color in chemistry. It's not actually a color as such, because white color normally disperses to form the blue, the indigo, the violet, the yellow, the orange, and the rest. So these ones are non-colored ions. So the only remaining ones are colored ions, which are insoluble. It goes even without being told they are insoluble. So blue precipitate insoluble in excess, that is copper ions present. If you get green precipitate insoluble in excess, it is iron 2 ions. It is a green precipitate, but it is insoluble in excess. That is iron 2 ions present. All of these ones are present. That is why I didn't have to write, because I think it will be easier when I say, is it present? So all of these ones are, let me just write this, a big one. So blue precipitate insoluble in excess, copper ions present. Green precipitate insoluble in excess, iron 2 ions present. And actually this one is iron 2 ions. You don't have to write Fe2 plus ions. Hiyo peke yake ni inasema it is iron 2 ions. That is why I call this one iron 2 ions. So this one is iron 2 ions present. Brown precipitate insoluble in excess, iron 3 ions present. Hii mtasahau kweli, si imekuwa rahisi. So of course you're supposed to remember the 3, first of all, colored ions. Na useme hizo kwanza, unasema color yake. So if it is now there's normally confusion that normally comes in, especially when you have blue and green. I don't know if blue and green are close. Mimi sijawahi jua kama zimekaribiana, so but you'll find a student say hii inakaa bluish bluish. I don't know. I don't know. Now let me ask you this. Let me just ask you this. What is the color of this side? Are you seeing the place of there is a casa? Pale nimechora sako. What is
Green,
the color of that place?
green, light
Green.
green.
Yeah, but it is green. Si ndio? Actually, the solution that you'll get mara mingi inakaa hivi venye hii sako iko venye nimesako ndani eh? So and then you'll find somebody still saying it is blue. So I don't know. So you should be very keen. Actually, ukifanya hizi vitu nilisema tena unasahau shida uko nazo home kwanza. Forget about the problems that you have. Because problems normally change color. I don't know if you know that if you have a lot of problems it will change color. That is why unapatanga watu wenye wamekaa kwa barabara anaambiwa uliona hiyo gari ilipita ya blue. But because alikuwa anafikiria shida zake anasema hapana, hakuna gari ya blue ilipita, yenye ilipita ilikuwa green ama ilikuwa yellow. And they argue. But because the mind was clouded that time because of other problems, they are right actually. In their minds they are right, but they are wrong. Yeah. So do you want these notes ama zile zingine as we continue?
Teacher, hizi ziko simplified vizuri.
Yeah, that is why I wanted to bring this one. Yeah, I was also nilisikia vibaya time nilitafuta kwa, so at least now I have them. I have converted it to my PDF, so it becomes quite easy. Now, there's something else now that is different. When you add aqueous ammonia, there's some slight of something changing, and this one is because of complex ions being formed or complex salts being formed or the double salts being formed. So hii kidogo kidogo inabadilikanga, very small portions are changing. For example, white precipitate soluble, it is no longer ZAP. So this one we now have zinc alone. We have white precipitate insoluble. We have aluminium. This one, of course, there's another one. This one you can remember. I normally call this one MAP. So this one is MAP. Let me just write. But hata we utakuwa unaona. So ile ingine tulikuwa tunasema ZAP. This one is normally called MAP. It is normally helping students. Actually, those students in class, unakumbuka tu, when you're talking about ammonia, aqueous ammonia, this one has been written in full. So mara mingi utapata imeandikwa, again something before we continue, utapata imeandikwa ammonia. This way, wewe usikue na wasiwasi, it is the same thing, or ammonium hydroxide. So hizi zote zinafanana. So it is the same thing. So this one is MAP, present, which means now magnesium, when you add something and it is insoluble in excess, you say now it is aluminium, or which one is magnesium, aluminium, and lead present. Now, when you don't have a white precipitate formed, there's no white precipitate formed, we have those soluble ones. And the only thing that we are bringing here now is calcium ions, which most of the nimesema, for you to get it correct, for you to get everything correct, except for zinc, which is only one. The rest, if you have two or more, we jua lazima uongeze uandike mbili. So I am giving exceptional for zinc. So it forms a white precipitate that is soluble in excess. You say it is zinc ions present. Now, the rest, because it has more than one, you must write two for you to score all the marks. In fact, you'll find that the marks that are given out here are more. Yeah. Ya zinc utapata wamekupea 1 mark, but the rest you find wamepeana 2 or even so that you can observe, because the observation of course will have more marks than the inference. The observation normally have more marks, but I think we will see We will see about that when we reach there. So nasema hii, when there is no white precipitate that is formed, most of the times actually students forget the calcium. So watu waandikangi calcium, and there is a reason for that. It has been said very well everywhere that the salts of potassium and sodium and ammonium are soluble, all of them. So you don't have to andika calcium. You can just write sodium and potassium ions present, or now I said unaweza andika zile zote ziko huko juu, kina zinc, kina aluminium, kina lead. You unaweza andika MAP and zinc absent. Of course you still score the mark. So nasema hii unaweza andika the positive side and the negative side. Any query before I continue? So we are done actually with the non-colored ions, which is white. So the remaining ones ni zile sasa zenye tumezoea. Yes. So the remaining ones ni colored ions, which we have the copper ions, the iron 2 ions and the iron 3 ions. Hizo ndo zimebaki. Now, so we continue. So light blue precipitate soluble in excess to give a deep blue solution. Of course, it is blue. So kama imekuwa light blue, it can dissolve. Of course, the observation is very important. It was light blue precipitate, which dissolved in excess to give a deep blue solution. The other time I had given you the meaning of light blue, and now let me do this. So I'll do this. Okay. So I'll do this. Let me just do this. And then I touch on this one. And then I do this. This one is very important. Now, for observation number 1, ni few drops. That is, nimesema tunaweka how many drops? 3. Few drops, that one. And then I touch this one is in the excess. Are you seeing the difference of those blue?
Yes.
Yes, there is a difference. So because there's a difference, you are supposed to write that one. Now, that is why I was saying, when you're doing a practical, it is very important to be very keen. You be very keen. That is observing, watching what is happening, seeing what is happening. You are supposed to be very keen. So light blue precipitate, which is this one, which dissolves in excess to form a deep blue solution. Yeah, so that one is very important, which is copper ions present. And then you have green precipitate soluble in excess. Of course, now it is iron 2 present. And then we have brown precipitate soluble in excess. It is iron 3 present. So, of course, the colored ions are very easy to remember. The only one that is different is maneno ya copper. Now, when we were in Form 4 salts, I thought about formation of zinc, why it is soluble. It is white precipitate because of formation of zinc hydroxide, which we said most of the hydroxide are insoluble. But ukiongeza in excess, it normally forms a double salts or complex salts, and that complex salts is because of formation of zinc ammoniates, which is now soluble. Now, this one is also formation of copper ammoniate, which is now deep blue. I think you can go and check in your notes. It is there because I shared the notes of salts and written actually. Yes, so it is, so the others are the same. I want you to see. Here we don't have a problem with this one because it is the same uko juu na chini. The only difference in copper is it will be dissolving to form a deep blue. But that one, it is insoluble, but it is still blue. So the colored ion remains colored ion. What is changing is maybe the few things about the zap, which now we are removing up, and we make it the map in the ammonia. So no white PPT formed. We are still maintaining the same two. So we are still maintaining sodium and potassium, which is very important. So don't forget about those ones when you are discussing those. Unless there's a query in this one, I can continue.
Teacher, no question, but just clarification on mambo na hiyo graph. Hapo tukirudi nyuma kidogo. The same nini unaweza tumia pia for other subjects like biology, hiyo kuruka tu nini? Kuruka
Yes.
tu.
Yes.
Haina effect.
Actually, haina effect. The reason sometimes is the only problem with graphs. Maybe to just clarify, the only problem with graphs mara mingi ni you can't get a scale that is covering 3/4 of the page. Now, I normally advise students to kuruka because of take care of the 3/4 of the page. And that is only the main reason why. And then, of course, when you skip those two lines, the graph will be very neat because you will not be squeezing the name of the y or the x-axis somewhere. Atunafinyilia pale, and because now you know the name should come with the units. So you are told that it must come with the units. For example, you can say temperature. Is it in Kelvin or degrees Celsius? So you're supposed temperature, and then you put in bracket degrees Celsius or Kelvin. So
Yes.
And that one in chemistry, for example, it is a mark. Actually, naming of the axis. That is, you have named the y and the x is one mark. Each half. I don't think people even know that naming the axis is marks. So if you leave out the name, most probably you lose the mark. So that is why I normally advise. So of course it is advantageous to you, especially in the scale. And of course, again, scoring the 1 mark juu unaweza shindwa. Of course, now let me tell you, if the graph is wrong inside, you don't lose all the marks. I don't think students know that. I don't even think you know that. Ukiwacha usiandike ndani na umeandika nje vizuri, you still score a mark or two. Are you aware of that? So tuseme umeshikwa, we assume that umeshikwa na time when you are writing the naming the axis. So we assume that ulishikwa na time, so hukuingia kuchora the graph. That is the reason. So we will give you a mark for the two.
For just naming x and y axis.
Yes, you get a mark. Actually, you get a mark for naming x and y axis correctly. And I said the other time, now, because we are dealing with practical sessions, and this one, I don't know, I think you'll get. Now, we have, I said, they normally give you plot a graph of A. Nikasema hapa ni A. Hii kona, nikasema inaitwa nini? What did I say, by the way? Plot a graph of A against, hiyo kona iko against B. So yenye inakuja ya kwanza ni A, hii kona iko against B. So if you say energy, is energy iko hii side, against iko hii kona, B temperature. Very important. Don't forget that one. Iko sawa. We can proceed now.
Yes.
Now, remember, we are still dealing with the, it was a nice clarification. Thank you, Monica. Now, remember, we are still dealing with inorganic. Hatujaenda kwa organic. Now, sometimes they will tell you to test flame test. We have the flame test, which we discussed in the other one, but it was not very clear. So in the flame test, you have, again, you'll have to do observation and then you infer. What could that be? And most of the time, now let me tell you this. Of course, when you're in the lab, there's a difference between luminous and non-luminous flame. Now, when you're dealing with flame test, you must make sure that the flame is in non-luminous state. Now, I cannot tell you. Let me just ask that question so that I see if people can understand. Or people know what we are going to do. Now, what is the difference between luminous and non-luminous flame? It is something that is normally tested. Of course, I know it will be in your KCSE. Of course, it might not really come that way. They can ask you, they normally give at the number of, they give you a flame, and then you name maybe the sections of that flame, and then they tell you, how do we form the other flame that is not drawn in the diagram? That if they did a luminous, they will tell you, they are asking about how we form the non-luminous. So how do you form, what is the major difference between luminous and non-luminous flame? Do you still remember those things? I think I
Luminous,
can give you that
luminous,
one. Yeah, okay, you can say.
yeah, luminous flame, I think it is yellow in color and non-luminous is blue in color.
Okay, that is correct. That is difference number one. Let us mention about 4. So that it can take care of, to mention the 4, it will take care of what I'm supposed to tell you, Apochin. So number 1, we are saying it is color, yellow, blue.
Yeah,
Number 2,
luminous, non-luminous, burns with soot, and non-luminous burns does not have soot.
so we are saying luminous, iko na soot,
Yes, and
alafu non-luminous aina.
yes.
Yeah, and that one is taken care of by the color, by the way. Let me explain that one before we go to something else. Ukiwa nyumbani, ukiwasha moto ya what do you call this, ya kuni, na uwashe moto ya gas, gani inachafua
Ni ya
sufuria?
kuni na
What is the color of ya kuni?
yellow.
So unaona sasa venye unajua hizi, it is normally very easy actually. So we already have two differences already, which are very easy. Okay, number 3. So we have color, we have the dot, the other one in a produce suit, the other one does not produce.
The luminous is not, the luminous, non-luminous is hot than the luminous, the luminous.
Yes, so we normally say that difference normally brings a lot of problems. Let me explain this way. There's some people wanaandikanga kwa hiyo question, that the non-luminous is hot. Alafu wanasema the luminous is not hot. Is that correct?
I think non-luminous is hotter.
Yes, and then you say luminous is hot, but not as hot as the. Lakini ukisema sio moto, let me ask you, a student write it is not hot and then they want you to give them a mark. Na wewe unaweza shika moto ile ya kuni juu sio moto, si umesema sio moto? Wewe unaweza shika.
Hapana, ni moto bado.
Ni moto. Yes, you are supposed now to remember that it is hot, but not very hot. Not as hot. Of course, no. You are supposed to remember those things. Now, that one is after tunaweza fika na 5. So the first one tumesema ni color, blue, yellow. Suit, no suit. The other one is hotter, relatively, not hot like the other one. And then number 4, there's something I'm looking for so that I can answer that. We continue with question number 3.
Luminous burns with air hole closed, while non-luminous burns with air hole opened.
Yeah, that one is what I wanted actually. Difference number. Sasa hiyo difference utapata mwalimu ameweka flame ikuwe yellow or ikuwe luminous. And there are advantages of doing that. You know the advantages. Ile ingine haionekani na muko lab, so hii ingine lazima, after using the Bunsen burner, most of the times you are advised to make it luminous flame. Of course, now how you make it luminous is by closing the air hole. Now, ukipata air hole iko hivyo, unafungua sasa ndo ufanye nini? Flame test. Now, that one is number 4. Let us just finish the difference. I think I can give the last difference. Or you have the last difference.
No, you can give us, teacher, the last
I'll
one.
just tell you a hint and then you give me. I know you have that thing. Nile sasa watu wana. Now, the number of regions. Another one has 3, another one has 4.
Luminous has 3, non-luminous. No, non-luminous has 4. Luminous has 3.
Are you sure? I'm not going to tell you that one, but that one is the one of the last. So they are normally majorly 5, but the most important one is the one that I wanted, which I wanted us to mention. Neo ya air hole open and air hole closed. And there's a reason for doing that. There's a reason for doing that. So nasema ukikuwa unafanya hii sasa test for cations, but you're using a flame test, you make sure that the air hole is open, so that there is combustion, full combustion or complete combustion, so that it produces the blue flame. So if when we have the blue flame, the reason why you must have it in blue flame is because some of the colors produced could be the same as luminous flame. So and then you now do that. So the observations burns with a yellow flame, sodium ions. Yeah. So we have sodium ions as number 1. So inachomeka na yellow flame. Sometimes now there's a problem with this yellow flame, which I will explain when we've been, I don't know if it is here, in organic. When you are in organic, not inorganic, organic compounds. In organic compounds, we are talking about kinetones. When we are talking about organic, we'll be talking about alcohol, alkanes, alkenes, and alkynes. So again, there is one that burns with a yellow flame. So we talk about that one. So we have that one. Red flame, calcium ions. There's something that I will also take a picture for you. There's this chart. Kuna chart flani I have in my school. Yeah, flame test. Okay, I think I'll also take that one. So another one burns with a purple flame. Sometimes people will say lilac. It is okay. It is lilac flame. Lilac is normally close to purple, so it is normally potassium. White flame, magnesium. There are others that I've left out. Kina copper, which is green. Those ones. So there are very many, but I'll share them. I'll share that one. But the flame test now is normally the one that brings problem, especially with students. Inaletanga problem because sometimes you can't identify the flame, and then sometimes you are writing it is sodium ions, but you have been given it is organic. They normally tell you an organic compound has been provided with. So they have said organic. So watu bado wataandika nini? Juu imechomeka na yellow flame, bado watu wanaandika sodium, which is wrong actually. Juu wamekuambia organic. If they had said inorganic compound, ungeandika sodium. Yeah. But most of the time, the reason why I summarize this one, niliandika very few of them. Now, is because this one is not the best way of identifying the cations. The best way of identifying cations actually is using of sodium hydroxide and potassium. Sodium hydroxide, not and potassium, and ammonium hydroxide. So using those two is the major one. Now, I forgot to say, sometimes when the school doesn't have sodium hydroxide, they can bring potassium hydroxide, but they not give sodium hydroxide hailetangi very good results. That is why we prefer sodium hydroxide. But now the good thing about sodium hydroxide, it is normally the cheapest. It is cheaper than potassium hydroxide, so it is easily available. In fact, I'm very sure that at the time unafanya practical, ikikosekana kwa the school that you're going to do the practical, wakipiga the next school, immediate school, actually tutapata sodium hydroxide. That is how easy it is to get sodium hydroxide. There's no school that doesn't have sodium hydroxide. And of course, sodium hydroxide, I said again, it comes in solid form and then you dissolve. And you dissolve following now ile rules, formation of molar solutions. Remember formation of molar solution or preparation. Very important. I hope tunaelewana hapo why the flames are very few. Yeah. And of course, this one was, this one was, I remember it was tropical. Yeah? So let me confirm if So I have the hard copy. If I send this one to you, you can also print alafu kwa unapitia. It is very few. Actually, this one is very few. I think it's around 9 pages or 10. The rest, 8 is just sample questions or predictions. Huh? Yeah. So we have another observation. We have another something now. Vitu nimefanya hapa ni vitu unaweza ulizwa. Ukiingia exam room na upate zangu haziko, zingine zipo, you don't say sikusema hizo. Ati hatukufunzwa zenye they have given us something that I've never seen. These ones are some of the things that could be that I used to taste this cation or that I used to taste the inorganic substances. Now, so there is another one which normally addition of 3 drops of sulfuric acid. They normally give you sulfuric acid. They can give you sodium sulfate. All of these ones are soluble. Remember, they're giving you a solution. And then when you add and it forms white precipitate, remember the insoluble sulfate source. So these ones actually stays for sulfates. But we are not tasting sulfates as such. We are tasting cations that combine with the sulfate to form an insoluble salt. And we have calcium sulfate, which is slightly soluble or partially soluble. And then we have also barium sulfate, which is insoluble. And then we have lead sulfate that is insoluble. So ukiona anything that has a sulfate, unajua, una taste for salts or cations that form insoluble salts, insoluble sulfate. That is why nilikuwa nasema salts is very, you remember tukiongelea maneno ya salts nilisema hata tukifanya salts form 2 I repeated the same thing in form 4 nikisema tu tulifanya hii lakini tunafanya tena. There is a reason why I normally do that, because if you forget maneno ya salts, most probably will not score again in practical, especially the qualitative analysis. You will lose marks in that one automatically. Now, if you added HCl, so when you add something that has sulfate, you are testing for insoluble cations that combine with sulfate to form an insoluble source. So this one, which I have mentioned. Now, addition of 3 drops of HCl, I can also predict that you are testing for silver and from chloride ions. We have chloride salts, and then we said all are soluble except this and this. So we are testing for those that are insoluble. Now, so when it forms a white precipitate, it is lead chloride, which is soluble on warming, and then we have silver chloride, which is insoluble. So these ones are silver and that's present. Now, before I proceed to question number, of course, number 6, my internet is misbehaving now. Let me confirm. But it is mine. Can you hear me very well before I continue? Anytime the internet says unstable, I don't know. I find that students normally ama inapotea kidogo. Am I clear?
Yes. Teacher, sasa hiyo ndio uko clear, but hapo wakati ulikuwa unaanza ku explain ulikuwa unakata.
Inakatikanga internet ikianza. I don't know, we are using Wi-Fi. No problem with Wi-Fi. I'm not using the bundles from the phone. I don't know. Also, that one has a problem. I normally prefer Wi-Fi because ausumbuki sana. When I use the phone, somebody can call ikatike or those kind of issues.
Yeah. So, teacher, can you repeat hapo?
I'm going to repeat number 5.
Yes.
So when we're adding 3 drops of HCl. When you are discussing about the salts, solubility of salts, niliongelea kuhusu nitrates, I spoke about chlorides, I spoke about carbonates, which other one? Sulfates, nimeanzia chloride, carbonates, sulfates, nitrates, yes. Nikasema all nitrates are soluble. All carbonates are insoluble, except of course the group 1. And then I went to sulfates. All sulfates are soluble except hizo za juu, calcium, which is slightly soluble, barium, and lead. And then I went to chloride and I say all of them are soluble except silver and lead, but lead chloride is soluble on warming. Now, hii kitu wanaulizanga sasa. The next question si umeongeza na ikaform hivyo. So ikakuwa white precipitate ikaform, so your inference will be lead ion and silver ions present. Question number 2 after hapa wanakwambianga warm the solution. If you warm and it dissolves, you say it is lead ions because lead chloride is soluble in warm water, but it is in silver is insoluble whether it is warm or cold water. Lead chloride actually is soluble in warm or hot water, but insoluble in cold water. So the next question on Ulzanga is warm the solution. So if it dissolves, unasema ni lead chloride or lead ions present because it is lead chloride which is soluble. Sio kama mnaelewa kitu nimesema? I was just adding something on that one. Is it making sense?
Yes.
Yeah, so that one is very important. So easy questions, this one I'm just giving, it is just a guide. But the main issue or the main understanding should have come in the source. That is why nilisema source in Form 2 is so dangerous that it can affect the results of very many people. But I don't think many people know that. Because actually, kitu tuna discuss hapa sahi, the solubility of salts. Solubility of salts. Okay. Addition of 2 drops of potassium iodide, yellow precipitate, again it is salts. I want you to go back to salts. There is a decomposition of salts. When you decompose salts, there was the one that you're finding that it is yellow precipitate or it is yellow, white when cold, those things. And it normally affects, let me just mention, it normally affects mara mingi lead and zinc. Where you have it is yellow, orange, white, and yellow. When it is hot and cold, different colors. I'm not going to touch on that one. So when you add that one, it forms a yellow precipitate. Lead iodide actually is yellow. So unless there's a query, before I continue to another page. Yeah. We are done with the testing cations. We are testing cations. I want us to test anions. But I want you to understand that you are supposed to be very keen in the observation so that you can infer. Now, this one is very good because wanasema observation now inference. So unapaswa kusema lead ions present. The only thing that is missing actually is here is only writing. Kitu tu yenye sikuandika kwa these notes is present. I'm even thinking that I should have written now. But because I was when I was doing these notes, I was quite new in the profession. Alafu nilikuwa naziharakisha because I thought nitakuwa nawaambia. I never thought that I will teach an online class and then it will have to be, it's required this one. So yellow precipitate means it is lead ions present. The same with white precipitate in the other one. So unless there's a query, do you have a question? Is there a question before I continue? I wanted us to finish for test for anions. Hata kama hizo zingine zitabaki, but anions and cations normally zinatembea pamoja. Because as you can even, if you have realized that, of course, HCl again is used to test for chloride ion. So they normally move together. Now, test for anions. The major anions that we have actually in that particle, ukiingia tu hivi zenye tuna test ni these ones that I've mentioned. Sulfate, So let me just use the pen so that people can. Sulfates zinaandikwa hivi. Nobody should, so that people cannot forget. Sulfides zinaandikwa hivyo. Sulfites 3, oxygen. Sulfates 4, carbonates is written that way. Chloride is Cl negative 1. So these are the radicals with 2. These are the radicals with with 1, valency of 1 or oxidation number 1. Alafu hizi zenye zinakuja hivi ni 2. That one is very important. Very important. Don't forget that one. So so we have chlorides, nitrates, and hydrogen carbonates. Now, before even I wrap that one, let me just tell you something. Ukiona nitrate, you're adding something that is nitrates. For example, you're adding sodium nitrate. You're adding aluminum nitrate. Yeah. Anything that is nitrate, wewe jua, you are not tasting what? You are not tasting something that has that thing. So inakuwa rahisi. So ukiona add barium nitrate, you know now, you go back to salts na ukumbuke. Kwa salts tulisema gani ni insoluble? Which insoluble source? We said all sulfates are soluble except barium. So we know that hapa tuna test nini? That is why nilikuwa nasema you are supposed to predict. Now, by the way, kwa salt, which barium salt is insoluble? Acha tu niwaulize before I continue. I'm waiting for your answer. I'll wait for you today. Which barium salt is insoluble? You want to predict. So mnakumbuka tukasema ukiona hii ni nini wamenipea barium nitrate, so inaweza kuwa ina taste nini. You are supposed to think in that direction or think in that way. What that means. Yeah. So which barium salt is insoluble? Ukienda kwa salt. Yes?
Barium sulfate.
So barium sulfate is insoluble. So unapaswa kujua hii most probably ina taste sulfate ion. Yeah, so you can predict and know. So observation, white precipitate. So if you saw white precipitate, the inference is sulfate ions could be there. Sulfite ions could be there because sulfate and sulfides are sisters. And carbonates. Remember, all carbonates are insoluble except the group 1. So barium carbonate didn't, so it could be a carbonate that is there because it will form barium carbonate, which is not soluble, which is white precipitate. So if it forms, so in short, what I'm saying is a white precipitate, if a white precipitate is formed, you can say the inference is sulfate, sulfite, or carbonate ion present. Now, remember the rule still applies. If you have more than one inference, kama ni more than one, let me just repeat. If it is more than one, the correct answer you should bring should be 2, at least 2. Should be having at least 2. You should write at least 2. So for example, I normally advocate for, because these ones are sisters, these two, sulfates and sulfides, nasemanga andika hii, you will get the whole mark. So it is sulfates and sulfides present. Because sometimes you can be in a hurry na usahau hiyo. Now, iko sawa? So we proceed. So if you are given barium nitrate, you know that you are tasting the sulfates, sulfides, and carbonate. Now, we proceed so that we see. If you are given followed by 5 drops of nitric acid, now this one changes everything. And this one is normally a question that is normally there. So number 2, you add 2 drops of barium nitrate. So it will form white precipitate which dissolves on addition of nitric acid. So if it dissolves, you say it can dissolve the sulfite and carbonate. A super dissolve the sulfate ion. Yeah, that is what I'm saying. When you're teaching the practical session, it's normally very hard. Oh no, I feel very weird by the way saying all these. without actually adding the drops, literally. So bubbles of gas will be produced if the white precipitate is insoluble. So it can dissolve on addition. You say now these ones are, it can dissolve, these ones are present. And I gave you another way of writing this one. If it dissolves, you can also write umesahau zenye unaandika sulfate ions absent. Kama imekataa, kama umekataa hizo zingine mbili, kukumbuka hizo zingine mbili, you can write if the white precipitate and then it dissolves on addition of nitric fibers, you say it is sulfites and carbonates present. Yes. Lakini kama umesahau hizo mbili, unaandika sulfates absent.
Sulfite ion.
Yeah, this one is sulfite ion. In a sulfate ion. And okay, let me just discuss something before I proceed. Maneno ya form. In form one, we remember when we're talking about the number of oxygen that are present. We said when there are two or fewer, for example, sulfate 8 has more hydrogen, more oxygen, not hydrogen, more oxygen than 8. Sylvia, you remember those things? Something we said there is something when it has that one, and then we have another one that has 8. So we say this one, E iko na more oxygen. More oxygens. So the number of oxygens in the 8 is many. This one has fewer. Do you remember kitu kama hiyo form 1?
Yes.
Yeah. So it's still applying in this case. Yeah, we're just using it here now. Don't forget those things. Those things are very important. Mumeelewa kitu nimesema hapa?
Yes,
So
teacher.
I'm assuming even this one, actually, bubble of colorless gas produced, which is that one is an observation again. Because so you can write bubbles of colorless gas produced, and again you say sulfite and carbonates present. Now, if you were to test this gas, actually you use calcium hydroxide, which will form white precipitate with calcium. That is sulfur 4, and the carbon 4 normally has the same effects on hydroxide, calcium hydroxide, in a form of white precipitate, which is calcium sulfite or calcium carbonate, which is insoluble. White precipitate insoluble upon addition of, so it is the sulfates now, which is sulfate present, or you can write hizo zenye ziko juu absent. Yes, now we are there. So unaweza andika hiyo na useme ni hizo sasa, that is the sulfite, this sulfite, alafu pia unasema hata hii carbonate, by the way, but mostly it will be, if you forget maneno ya carbonate, don't forget the sulfate and sulfite, because hizi mbili sumunaona tukiwa hapa nilisako the two of them, because those ones are the major ones that we are testing here. So you can say these were the two zenye tuliandika huko juu are absent. That is very important. I'll share these notes after this.
Mark.
Sorry?
Tuseme nimesema hapo when the white precipitate upon adding nitric acid is insoluble. Nikiandika sulfite ions bila kuandika carbonate absent, nitapewa full mark.
You'll get the full marks.
Oh.
You'll get the full marks. There's a reason. This one is normally very special. Now, when you talk about the barium nitrate, hata ukienda sulfates, test for sulfates and sulfites, tunatumia hii. We are test for sulfates and sulfites ni peke yake. This one is a test for sulfates and sulfites. It is not test for carbonates. But I added carbonates Because the main reason why I added that one is because of ile story all carbonates are insoluble. You remember that one?
Yes.
Yeah, so
Yeah.
nimeongeza tu ndo niwakumbushe carbonates zote ni insoluble except the group 1 and ammonium carbonates which are soluble. And then of course remember those ones that do not exist.
Mm.
Yes. So actually this one we normally use to taste sulfates and sulfides alone. But the only reason I brought carbonates is because ile maneno ya carbonates salts is coming up. Yes. Any query? Any other query before I continue? Tuko sawa. This one is very easy, si ndio? Shida ya hii
Ikiwa pia theory, teacher.
ikiwa theory, yeah, that is what I was saying. It is not making sense when we do theory. But I wanted only you to see, so that ukiwa, when you'll be in the practical session, at least you'll be having an idea of, walikuwa wamesema hii nasema hivi. Yeah, I wish I would be there. That's why I was telling you, it's not making sense when I handle the practical sessions, theoretical. I don't know if you have the same feeling, but I feel it's normally weird for me. I never teach these things, by the way. These ones I normally teach the form 4s, especially when they're almost coming to the exam. Na tusiwezi fanya practical, yani wameshafanya practicals. Now, I am happy that nyinyi mshaifanya practical. So you are better off. So nyinyi mshaifanya wote. Yeah, so it is better off. So at least you are saying, tuliaifanya, by the way, I should have written this way that time. And again, the good thing is we are just a few days to the practical. I don't know, it's a few days actually. Very few. About 3 weeks, and then you do your practical. So I'll still share these ones so that you can use. So number another, yes,
tutapitia hizo practical zote tumediscuss kwa theory.
yes, it is there. Actually, the practicals that madam, I think we were testing. All of us were checking if it was a good practical. Now we checked most of the practicals were actually good. It is touching on all of these ones, everything that we have touched on. Maneno ya titration iko, maneno ya testing for using sodium hydroxide equals using potassium hydroxide iko, testing for this one now. Anions is there. So zote ziko. So you uko tu, for now, I'm saying I'm just presenting something, of course, now, and then I'll share it. I think I'll just, before you sit for your exam, nitarudia tu bado the same thing. Tunapitia tu that time. But now you'd have done a practical. Now, if you were around my school, or if I was teaching around the place that you are, I would have invited you actually. You do the practical with my students. But now since we are far away from each other, there's no problem. But I think nobody atakataza mfanye practical. Even if you request the nearby school, I don't think they will refuse to give you a practical with their students. Actually, they will not. Very few will, but I don't think anybody, but because you are student. Yeah. So we continue. So addition of 2 drops of acidified barium nitrate. Now, sometimes they tell you it is acidified, so it is well precipitate sulfate ions. Acidified, there's a reason why it is called acidified. Acidified, they have added a few drops of an acid, mostly sulfuric acid. Mostly they have added sulfuric acid. So we say sulfate ions present. Now, when you talk about lead nitrate, lead 2 nitrate, again, you are supposed to remember the insoluble salts. Yeah, lead nitrate, or the lead. You know, lead, all nitrates are soluble. That's why we use nitrate, because it will be a solution. Now, you're supposed to remember lead, means the lead as it dissolves. Number 1, sulfate. So you know lead sulfate is insoluble. Number 2, sulfides. Both sulfates and sulfides are normally sisters. Number 3, yenye tumediscuss tu sahi is Chloride. We say chloride is insoluble in cold water, but it is soluble in. So chlorides they are insoluble. And then number 4, of course, now all carbonates carbon are insoluble. Except. So you are supposed to remember. These are, lakini nimesema, remember mimi nimesema, at least you should know at least 2. You can write 2. The only problem with this one is wanakujanga kwa kwambia warm, ukiwarm ina dissolve. So inakuwa hiyo peke yake. Hizi zingine haziko. But let me just wrap that up. So lead nitrate, lead 2 nitrate is normally used to test for sulfates. This one is sulfite, yenye na rub, and I'll rub as I give the name. Sulfite, chloride, and carbonates. Na nimesema, there is no problem. Unaweza andika mbili. You can write only 2 of them. You don't have to write the 3 or the 4. So when it forms a white precipitate, you have sulfates, sulfites, carbonates, and chlorides. But the major ones that we talk about, we do not normally talk about the carbonates mostly, but we majorly talk about the sulfates, sulfides, and the chlorides. Because the next question most probably will be something that will be touching either. We will see. So add to addition of 2 drops of lead 2 nitrate followed by 5 drops of nitric acid. You see now what is happening. So the white precipitate, which is soluble on addition of nitric again, is manana sulfites and carbonate. Again, sulfates have a negative observation to this. Actually, we'll talk about that one. So bubbles of colorless gas. It is the same with the first one. Eh? So white precipitate, when it is insoluble upon addition, we have the 2 of them, sulfates and the chlorides. But mostly it is sulfates. Now, chlorides you normally tasted using warming, uchoma, or you warm that solution. I hope it is here. Yes, and there is addition of 2 drops of lead 2 nitrate followed by warming. This one, actually, this warming is autocorrect. Eh? I didn't even want to change. Nikasema tu people will not forget that one. So addition of 2 drops of lead 2 nitrate, and then you warm is actually test for chlorides alone. Now, so white precipitate which is soluble on warming is chloride ions. Now, what about if it is insoluble? Okay, warm. So we have sulfates, sulfides, carbonates present. Na nimesema hizi unaandika mbili, you should remember around 2 of them or only maybe 2. So this one is present. So ukiwarm na dissolve, I want you to remember that lead chloride is insoluble in cold water, but it is soluble in warm water. So ukiwarm na dissolve, unasema sulfate, sulfate and sulfite. Mara mingi we might not, or actually if it white precipitate which is insoluble on warming, you can write. Unajua time ingine watu wanasahau, unaweza andika chloride ions absent and you will get a mark because we know that you know that this thing is soluble in warming, lakini juu tumewarm na ikakuwa insoluble, hizi haziko zenye ziko sasa sijui, lakini yenye najua haiko ni you still get a correct mark or you get a full marks because it is only one. Is it making sense what I'm saying?
Yes.
Sometimes unapata unasahau and it is okay to forget. I'm saying we are human beings. So you can say something, the other one is missing. I think these notes are better off. So I think these ones are better off. Okay. So let us continue. I don't know if you have another one. Yeah. We have this one. Addition of acid, 2 drops of acid, acidified. So we have white precipitate. So that's why nilikuwa nasema this one mainly is normally used in testing sulfates and chlorides. You remember when I talked about that one? So it is normally used in testing the sulfates and the sulfates and the chlorides. The other ones only come in because of we know they are insoluble salts already. When we talk about salts, tulikuwa tunajua hii ni insoluble salt. So bado ina affect that one. Now, And the addition of this one, I can say in summary, number 8 now is addition of 2 drops of oxidizing agent. Normally an oxidizing agent. Oxidizing agent ni acidified potassium bichromate 6, and then we have acidified potassium manganate 7. Iso. Now, maybe bromine. Yeah, maybe bromine water comes in here also. Which bromine water is normally very risky. It is very risky. So colorless. So when you add acidified, of course, the observation, we have very many observations in this one. But the first observation you're supposed to see is the color change. Orange to green for orange to green. Orange to green for the dichromate 6, and then we have purple to colorless for manganate. So inakwanga tofauti. So those ones are very important for you to remember. You're supposed to remember those ones. So of course, another observation is bubbles of gases. So we'll have the sulfites ions. Sulfate can be here, by the way. Sulfate can be here, but mostly we normally use oxidizing agents. That means it normally we are saying what is the function of an oxidizing agent? Because I talked about oxidizing agents previously. So oxidizing agents actually is supposed to undergo, is it undergoing reduction or oxidation? So that people, tuone kama watu wanakumbuka kitu tulidiscuss. Do you remember what the process that it undergoes? Maneno ya oxidizing agents. But the best observation you can give here is the color change. And of course, there is normally formation of bubbles. Not necessarily effervescence, but bubbles. You don't remember. Okay. So bubbles, you see now there's another bubbles of colorless gas, but again now the color is retained. So that means it is carbonates that are present. Now this one is a special case. This one is a special case of this one. That is why niliweka star. More niliweka star. It's normally a very special case. It's rarely tested. I don't know why it is rarely tested, but I didn't want to leave anything out. I wanted to touch on everything. So in case ikuje, students are not saying they were left out. Because most of these ones, this one actually is not taught in I don't think it is taught in high school level. I thought it was taught in another level. But I thought because I'm doing these ones, let me just touch on everything. So that is why Niliweka star is normally a special case. Because mostly the ones that we normally taste, actually, is the one that there is color change. You can witness the color change. Orange to green, purple to colorless. Those ones are very important. I hope there is that one for purple. Let me just confirm.
Yeah.
Yes,
There is something
Mom.
else. Now, which word are we supposed to use? Turns or changes? The purple color changes or turns?
It is the same thing. It turns from, now the problem is English here. So it turns from, when you talk about turns from, you are supposed to say from this to this. And then you say color changes from.
Or from.
Yeah, what I'm interested in is the color change. Your color change. If you write for me, the color changes. You don't telling me now from which to which. That is where the problem. Actually, turns, there's no problem. If you write turns, you are correct, but sasa hujaniambia. Actually, mtu akiniandikia by the way, color turns or color changes, hiyo ni wrong.
What if you say color turns to green? Na hujasema from which color?
Yes, I want to know now where it was coming from. Ilitoka white na ikakuwa green because it is possible to. So you don't leave out something. In fact, mimi, if I was marking your answer, na uniandikie orange changes to green, that one is correct. But if you tell me the color change turns to green, That one is wrong because nilianzia wapi? Huwezi sema naenda Nairobi, hata ukiwa kwa stage wanakuuliza unatoka wapi, unaenda wapi, si ndio? You don't
Mm.
you don't go to without starting from a place. You start from somewhere. So it is correct to say orange changes to green. I know those are the colors already. Yeah. So but I need now the colors because there are many colors. Unajua kama colors ingekuwa mbili peke yake, ingekuwa orange na green, ingekuwa najua ukiniambia changes to green, that means it was coming from orange. But we have very many colors. In fact, we have more than I don't know 100 colors. So if we have more than 100 colors, so I need to know from those 100 ilitokea wapi. Yeah, I think that is a good question also. Any other question before I continue? There's something I wanted to touch on before. Of course, I know class will run out. We'll run out of time before tumalize, but I want people to understand. I'll send these notes. Kila mtu amekubali iko sawa. So I'll share it in the group. I don't know how many we are. Tuko sisi ni wawili tu. But it is okay. It is okay. So this one niliweka hivyo because it is normally a special case. Kind of special kidogo. Now there's something very I know kila mtu amengojea hiyo. Hii
Teacher, sijui
sasa
kama
ndio kila
utaweza kutuandikia hii, kama utaweza kutuincludia huko kwa present, ama haiwezi kueditika.
This one cannot be edited, but let me try. Let me try if I
Okay.
can edit if I can
Ikiwa
edit
na
in
Bible na
yes.
Bible.
But I think yeah, you know now niliscan the hard copy. This one is I scanned it yesterday by the way. Hata ukiona and I used my phone. Hata sikuenda kwa I just decided to use the phone because it was in a hurry. Nilisema lazima leo niwaambie hizi vitu. So yesterday night nilipata hii, nilikuja nayo from school. So when nilifika nyumbani I decided to scan and then I had to convert blah blah. It is a long process to PDF so that it can be used now. But I don't know so can I share it first or I just have to write it first? Because now if I have to write, I have to write it from my hard copy. This one is PDF. I don't know if I can convert it to Word. I don't know. I'll try if it is convertible.
Unaweza tuma, tukikuja tutaandika. Tukikuja kwa practicals tutaongezea.
Okay. And of course, the reason why I converted to PDF, yes, Maura, before?
We remember to come with the graph book on practicals.
Yes. Please remember, because I don't know if the school will provide, now I don't know the school that you are going to do the practical, but it is better to be ready than to be sorry. Better to be safe than sorry. So that musiko mnakimbia kuendea
vitabu.
Muna waste time kuendea graph papers. So I think it is better to come with it to the practical because most probably you'll have a question that has a graph and it is better to practice. You can do alafu, of course, I don't know, maybe they will tell you mumalize the practical and then you do the graph later, you send. I don't know, but it's still okay. But it is better to practice hapo ndo akucorrect hapo. Kuliko ile yenye unajua ukicorrectiwa hapo ina stick more than ile yenye unaambiwa kwa simu, I'm texting you, it was not supposed to be this way. I want to tell you, it was not supposed to be this way, it was supposed to be this way. And then you try that way now, immediately. Siko sawa? Now, of course, the reason why I converted this one to PDF was, I know some of you would want to print this. So it is printable. You can print this one. Yeah, so in case unataka ikuwe hard copy, unaiprint pia. So that is why I brought it out to be in PDF form. PDF is the easiest to use. So now, there is this question that is very common and that many students lose. This one was what I was targeting actually. Take about half of the solid G, solid K, solid A, solid B that you are provided into a dry station and eat it gently, then strongly. Actually, what wafuatangi hiyo instruction ya kueat gently alafu strongly. Watu wana eat direct far And there's a reason why it is you eat gently and then you eat strongly. So that when you eat gently, ukiit kitu pole pole, you
Gently
can
ni
observe
kuhit
it.
ukitoa.
Yes.
Sasa gently is it una hit ukitoa kwa moto, una hit ukitoa kwa
Yeah,
moto?
yeah, ama unaeka mbali na moto. Unaona?
Eh,
Student yeah, unaeka mbali. And they normally give you a tasty boulder. So kwa hiyo
una
holder unaeka mbali kidogo. Actually you can observe kama ni kama these things normally taste you ni kama mafuta. Mafuta ya solid. Let me say mafuta ya solid, or we can use cheese or something. Na ukiweka cheese kwa sufuria moto
itayeyuka.
itayeyuka. Kama moto ni kubwa, would you have even time to observe? Si inayeyuka haraka. Lakini moto ikiwa kidogo, unaona ikiyeyuka pole pole, si ndio? You can even move it pole pole. Yes, that is the reason why we say gently. But people don't want to follow that gently. Wanaenda fly. Now, this one now is what normally happens. The colorless liquid form on the upper cooler parts of the tube actually ina mingi. But people do not which hawaoni huko juu, wanataka tu kuona huko chini. So we can say the solid is hydrated. So the water of that means the water of crystallization imekuwa loose kwanza. That is why. So the difference is the hydrated solid. Sometimes they tell you to test using litmus paper. If the litmus hydrated, nilisema wakikupea litmus paper na wamesema utest gas yoyote, kitu ya kwanza ni kumwagia nini? Maji. Wewe jaza maji tu, mwagia maji ya litmus paper. Wakikupea tu hivi maji, you will get the correct observation actually. So the reason why I'm very happy teaching this one is I'm not at close school. I have my practical on Monday morning. The chemistry practical. I don't know. I'll share the same practical with you. I'll scan it because it was bought by the school. It was an hard copy. I'll just share. And maybe I can share the marking scheme so that you see how you are supposed to be answered. So on Monday, before we come to class, nitakuwa nimetuma the soft copy of the practical that was done and how it was done. Yeah, so that you can discuss it on Monday for the sake of just understanding. I hope that is okay.
Yes.
Hiyo itakuwa sawa. So we just discuss that practical. Yeah, ndio watu waone venye sasa what we are supposed to do hapa. So we'll be checking the question and then we check the answer. I don't know, I was even hoping that if I get time, I can cut my my presentation. That we have a question on the left side and then the answer on the right, so that it becomes easy. But we will see. And then if the litmus paper changes, if the blue litmus paper turns red, and the red, of course, now there's a problem. Before even I continue, there's a problem with students. Umeweka litmus paper mbili ya red na blue, lakini juu ya blue imechange, you don't say what has happened to the red. You lose marks for that. I don't know if you have ever been told that.
Yeah.
Yeah, you are supposed to say kama blue imechange to red, andika hiyo na useme red haikuafektiwa, so the red remain red. Those are it is an observation actually, ama say observation kama ilibaki haikubadilika na inaonekana. Yeah, so that one you can say acidic gas produced. If you don't know actually the acidic gases, you can say acidic gases produced, but most of the times you're supposed to know the acidic gases, which I'll talk about those ones. Iko hapa chini. Kama ni red litmus paper turns blue, blue remains blue. We have ammonium ions, which is normally producing the basic gas, ammonia. Bubbles of gas, colorless gas that blows off. You remember vitu inazima a burning splints ni carbon dioxide. So you're supposed to remember those. Yeah. Brown fumes. Now, brown fumes is normally tested for nitrates. I'll talk about that one somewhere else. It is normally tested in nitrogen and its compounds. I don't know, in that topic we'll discuss about this one. Please remember this one. The lighter glowing splint, it is still nitrates, but this is not oxygen. There is a gas in oxides of nitrogen that lights a glowing splint. Actually, we have I think it is two, nitrogen 4. Of course, we have nitrogen. So nitrogen, of course, gives negative results. We have nitrogen 4 and nitrogen 2. Now, nitrogen 2 actually relies a glowing splint. Sijui kama watu wanajua hiyo. So we have two gases that relies a glowing splint. We have oxygen, hiyo tunajua. And then we have the nitrogen 2, one of the gases in nitrogen and its compound. It relies a glowing splint. That is why we are saying nitrate prism. Hiyo msisahau. But I think it will be discussed. I feel it still will be discussed. Residue white when cold and yellow. You remember hiyo vitu nilisema special case of color when it is hot and cold ndo hizi. We also have lead. You can go and check on lead, orange, or I think lead inakuwa orange and yellow. You can confirm. So those ones, so zinc. White solid formed on cooler parts of. So we can say the solid sublime, and undergo sublimation. Talking of sublimation, when we have sublimation, please know at least 3 examples of things that sublime. Where you are two, at least 3. It is in Form 1, it is repeated in Form, I don't know, Form 3, Form 4. It is repeated somewhere. Another one, that's something that is question number 10. This one is the last one. I know you have another class by 10:30, so that is why I normally end class on Saturday as early. On Monday, I don't have a problem. On Wednesday again, there is a problem because of preparing to go for work. But on Monday, we can even do class up to 11. I don't mind because Nikulala. So I can shida, especially on Monday after closing. When we close schools, I think we can do whatever we want. Hata kama amwendi job on Wednesday, I still can handle up to 8, even from 6 to 8. There is no problem because I'm not going in. Unless I have another class, of course, with other people. So the last one is put the solid into a boiling tube, add about 10 ml. This one is also a very common one. Hii wanakwambianga add about 10 ml, alafu kisha add 10 ml, they tell you divide the portions into 5. Sasa kwa hiyo 5 utakuwa unaongeza kitu. So the observation dissolves to form a colorless solution. So we normally say it is a soluble salt. And now, because it is soluble and it will form colorless, you can say the colored ions are absent. So kama iko sawa, you can say copper ions, iron 2 ions, iron 3 ions, absent. Hakuna colored ions, ndio? Yeah, or you can say it was something else that there's another answer for this one, which is haikukuwa hiyo time, but it is now correct, saying it is polar non-polar substance. So find out about polar and non-polar substance. So why don't we start from there next time? Because I know you're supposed to do 1, 2 before you come back for your mathematics class. Unless there's a query. Monica and Maura, since now we are 2, do you have any question? Can we end it there for today and then we proceed another time?
No question, teacher.
Yeah, so we end it there and then we can proceed from this one is page 8, and then we now go to sample questions. We check how we could have answered the question, and then we say, okay, andika hivi, is it correct or wrong? Yeah, but now for now, just internalize, contemplate about what we just discussed, and then you see if it is making sense to you. Until next time, I wish you a very happy weekend and a beautiful day. Thank you very much for attending.
Teacher, you will send?
Yeah, I will send. Let
them?
me just share it immediately. Can I do
Sawa.
that now?
Yeah.
Now I'm sending. Do I have to send it to individuals? So I can post it in the group. Yeah.
Post it.
Post it.
Okay.
Yeah. Let me just post it in the group so that it becomes
Aye.
very easy. just right away.
Yeah.
Okay.
Thank you. Have a good day.
You have a good day.
Okay.